So alrighty, well I have that it's 3:31, so I will go ahead and start. My name is Patrick Michaud, and I'm the leader of the Michaud Perl 6 project, and have been working on it for more years than I care to name. My talk today is on Perl 6 lists and arrays, and kind of describing how they work and the things we've learned in going through and implementing them. As I go through the talk, if you have questions, feel free to raise your hand or shout them out at me. I will handle them in line as best I can, and try and do that because this talk is it's got a lot of information in it, but I'm not quite certain of the order of presentation yet, so I'll be figuring that out as we go. This, of course, is our wonderful Perl 6 logo. Hi, Camellia. Alrighty, so what are we going to be covering? I'm just doing our lists and arrays today. Hashes is from a previous version of this talk. Of course, as you know, if you've been programming Perl for any length of time, lists are just a fundamental part of being Perlish. In fact, one of the things that I liked about Perl when I first encountered it is that it had good support for lists as a basic data type, much better than all the other languages I was being chained to at the time. There are some significant changes in Perl 6 over Perl 5. So first of all, lists in Perl 6 are lazy. They can be infinite in length, and we have some new list contexts that are being used in various places. So I'll be going through some of those today. Whatever I don't get to today will be in my talk I'm giving tomorrow. So I'm going to go at whatever speed seems appropriate for the stuff. I think I have more than 40 or 50 minutes worth of material, so if you have something that doesn't make sense to you or that you have a question about that you'd like to learn more about, you can tell me about it either in the question section of this talk or between now and tomorrow, and I'll cover it in tomorrow's talk. But that'll be at 1:30 tomorrow in the same room. So first of all, about lists in Perl 6. I have lots of experience with Perl 6 lists and arrays. And of course, experience, the standard line that I have about experience is good judgment comes from experience, and experience comes from bad judgment. I have lots of experience, and I have lots of bad experience with lists and arrays. Michaud itself has gone through at least 5 separate implementations of lists and arrays in its multi-year lifetime. And the reason is because we would do an implementation and we would put it in, and then we would discover, oh, that doesn't really work. Well, we'll have to go back and fix it. And unfortunately, as I said, since lists are so fundamental to being Perlish, changing the list implementation usually necessitated ripping out large parts of Michaud and starting over. So it's been a pain. I'm hoping there won't be a 6th. I'm fearful that there will. There have been many synopsis changes. Now, the synopses in Perl 6 are kind of the specification documents. They're the plan for Perl 6. And the parts that deal with lists have changed almost as much as the parts dealing with regexes. So it's gone through several major refactors that, of course, the implementations have to keep up with. So the list specifications, if you go and look at them and want to learn all about lists, then you can go look at the synopses, and it says synopses 7 and 8 describe lists and iterators, and currently as of today they are wrong. They are very wrong. If you read them, you will be completely confused, so don't read them. I mean, really, don't do it. You've been warned. Don't go read them because it will throw you off. The version that is out there was written about 4 or 5 years ago, and it was drafted before some of the very fundamental pieces of even the syntax were set in stone, and so it gets those wrong. I'm working on the rewrite. I've been working on the rewrite for about 15 months now, and based on some work I did this last month, I actually think I'll be able to get much farther along in it over the next couple of months, so you can see it. So this talk provides the most current understanding of the spec as it will be when it's written. So it's definitely not written on what you'll find there. So some basics. This is some basic Perl 6 stuff for people who are not familiar with Perl 6. Arrays, if you want to create an array of words, then you can just declare the array and give it a list. The sharp angle brackets there, that's the same as QW in Perl 5. So it just gives you all of the words as strings separated by white space. So this gives us a nice list of 5 words. If you're wondering why I chose fruit, all of my computers are named after fruits. So this is my list of machines that I have at the house. So simply say words, and it will give you print out the list of words that's in the array. And just like in Perl 5, you can index into the array to get a specific element. So if I want the element at index 2, I just put brackets 2 after it and put it out. One thing to note that is different from Perl 5 is that the sigil doesn't change. That is, the sigil goes along with the variable name and not with the type of thing that you're trying to return. So now if you say @words, that's the name of the variable and it stays consistent. You can do slicing, same as in Perl 5. So if I just want to get the even numbered elements out of this array, then you just give a list of indices that you want to grab, and it will go and grab them individually like that. I'm sorry, what? Yes, correct. I'll fix that after the talk. Okay, for doing operations on the arrays, most of the functional forms that you're used to from Perl 5 are still there. So if I want to know how many elements are in the array, I can just do elems in the name of the array and say it, and it tells me there's 5 elements. If I want to pop an element from an array, I can do that with the pop keyword or the pop function and put it into a variable. Generally, when I'm writing and working with arrays, I prefer the method call form now, in which you put .elems, so that means invoke this method on this particular object, and that gives me the same sort of result. I find that the method call form fits, it binds tighter than the function call form, and so it reads better to me. But whatever you're used to using, there's more than one way to use it, no, to do it. Yes, you could do @words.elem.say. Here's some more examples. So push does what you expect it to do. There's a variety of ways that you can do map. So you can do the map functional form where you pass a block. Note the comma is required. That's a little bit different. And then the array. Or you can do the method form where you pass the block as an argument. Or you can do the indirect form where you pass the block as an argument like that. Or that's the list form. And so on. I'm sorry, what? Oh, is it gone?
Yeah.
Rakudo still has it.
It's supposed to have it gone.
Oh, Rakudo still has it. What is it now, or is there just no function? Okay. Okay, I missed that.
Yeah.
Apparently all of us did. Larry, file an email to rakudo-bug@perl.org. So you can also do sort, and you can do the method form of that as well. Arrays, as most everything else that you encounter in Perl 6, are objects. And objects can be held in scalar variables. In Perl 5, of course, we call them references. In Perl 6, they're still references, but we really hide the fact that they're references in a lot of ways. So you don't ever have to think about, do I have a reference or do I have the object? Perl 6 kind of knows what you're wanting to do. So here I'm creating an array, and I'm storing it in a scalar variable $words. And if I ask words, what are you? It tells me it's an array. Now, a Perl 5 person would say, oh, no, that's a reference. But the fact that it's a reference or just the straight object doesn't really matter much. In fact, you'll note I didn't have to dereference it. I didn't have to use an arrow or anything like that. Just the dot is sufficient, whether it's a reference to an object or the object itself. The dot is sufficient to get your method to where you want it to go. Here's more examples just using that same concept. So if you want a subscript, you just do the subscript. Don't need an arrow or anything like that. If you want to do a slice, you just do the slice. If you want to know how many elements there are, you just do the thing. So a lot of the referencing syntax that Perl 5 had in place, you just don't ever have to deal with in Perl 6. Yes?
So at that point, what becomes the benefit of using the @sigil? Do you get optimizations when the @sigil is there?
The @sigil will put certain constraints on what it can be bound to. And some people like to be able to use the @sigil to indicate something's plural versus singular.
Yeah.
So, you know, but if you wanted to completely do your program using only the $sign as the sigil because you really like PHP, you can do it. Yes?
Don't the an variable also automatically flag
That has to do with, I'm actually going to cover that in a bit.
Okay.
Yes, it will. It does control flattening as well.
And also with the scalars, if you said $food, $words, it's both one of the same 5 elements of memory, where @food was @words, but if you complete.
Would be a list assignment, right?
Yeah.
And it would do a copy. And I'm covering that a bit later too. So there's no special referencing syntax needed, and that is, in fact, here's an example of that. So here I have an array, and I'm going to do my $x equals words, so now x is referencing that array. And if you manipulate the array, you are manipulating the thing that x references. So if I add a word to words and then ask x, how many elements do you have, because it's referencing that same thing, then it will come back with 6. Okay, so list interpolation. In general, non-scalars interpolate or flatten into lists, and scalars do not. That's kind of the general rule that I keep in mind when trying to keep all of this straight. So here I have an array, A, B, and B, and they both have numbers, and A have C, which is an array reference. And so as Randall just asked, if I say A, comma B and put it into 1, this flattens out so that the array 1 here ends up with 6 elements, 1, 2, 3, 10, 20, 30. On the next line, where I have 2, and I put in A, B, and C, the $ there is your clue that won't flatten. It's a scalar. So even though A, B, and C are all arrays, the $ in front of the C prevents it from flattening into the thing. So the resulting array at sign 2 ends up with 7 elements. 1, 2, 3, 10, 20, 30, and an array, that array containing 3 elements, 100, 200, and 300. So the $ is your key to know if something flattens or if it doesn't. So if I ask for the element at index 0, I get 1. If I ask for the element index 6, I get the 100, 200, 300, because that element is an array which then stringifies, like so for say, or justifies, which we won't cover here. Scalar arrays don't interpolate, and that's true for almost all functions. So here I have at sign x, and it has 3 elements, and I say $y. It's a referent to at sign x. And so if I ask x how many elements it has, it's going to say 3. And if I loop over all of the elements of x, then they'll flatten out, and each one will be treated one at a time. So that's why I'm getting loop 1, loop 2, loop 3, because each iteration through this loop, I'm getting an element from x, concatenating it with loop, or printing it out. But if I use $y, which is actually a reference to x, but it's got a $ there, that means it doesn't flatten out. And so the for loop, oops, yeah, that's okay. So the for loop says there's only one thing there. It won't automatically flatten y out for you, because that's a scalar variable, and scalars don't flatten. And so this loop would be executed one time. And that one time, it would have $_ the topic set to $y, which is the whole array. So it would stringify that whole array, giving us 1, 2, 3, put loop in front of it, and that's what would be printed out. So now the question becomes, well, how do I get it to flatten out if it's in a scalar? And you can use an @ sign or .list to get the list form of an object. And this is true for all of the different objects that may happen to exist. So this is going back to my earlier example where I set an array to A, B, and $C, so it ends up with 7 elements. But if I put .list, that's telling this object, I want a flattening form of yourself. I want you in a list form that will flatten. And so the .list here causes this array to flatten the same way that A and B do, and thus this array gets 9 elements because it's been flattened in instead of keeping the scalar array. As opposed to .list, if you prefer to put an @ sign in front, that's a cast, saying I'm casting this thing into a list. And so if you just put the bare scalar there, it's only going to do one iteration, but if you cast it into a list first, then it's going to flatten it out and iterate over all of the elements. Yes? It's a method on the list. It's a method on the list. And we don't really have scalar and list context like we did in Perl 5. So there's not really, I mean, we have the context, but they have a different sort of flavor to them. Because of multi-methods, the thing being called can't know what context it was in. And it gets really bizarre from there. I may add that to tomorrow's talk. That's a really good topic. Yes, the parens are optional on that @. Some ats, they're not optional. Wait, I thought, is that the one that it's optional on?
Well, Michaud didn't do that for a long time, but it doesn't.
Where they're optional? Which, okay. Okay. I can never remember. The spec keeps flipping.
That $1 is going to work.
Okay. This is going to work all the time. So. If you want to go the other way, if you want to force something to not flatten, then you put a $ in front to make it into a scalar, or you can do .item, which is the method form. So again, starting from the example I had before, we have an array, and I'm taking A and B, and they flatten into place. If you scalarize them by putting the $ in front, then that forces them to be scalar arrays, and they don't flatten. And so this array at sign 2 ends up with two elements. The first element is an array containing 1, 2, and 3. The second element is an array containing 10, 20, and 30. And if you ask .Perl is our generic data dumper, then you would see that at sign 2 is an array consisting of two elements that are both themselves arrays. Okay. Okay. And Rakudo probably doesn't implement that yet. Does it? That's what? I'm sorry? Oh, okay. I think he's actually meaning since 2012-05. If you wanted to do .item, I didn't give an example of that, but any of these arrays, like here, you could do @a .item. No, that gives you the array in a scalar is a scalar, as opposed to a flattening object. Except the backslash actually creates what we call a capture. That's tomorrow's talk. Okay. Any other questions on those before I go on to laziness? Okay. So, lazy lists. So, laziness is one of the three virtues of a programmer. And this is my experience with laziness in Perl 6. So, laziness is the quality that makes you go to great effort to reduce overall energy expenditure. And I cannot tell you how much great effort I've gone through trying to get laziness into Perl 6. Impatience is the anger you feel when the computer is being lazy. My impatience has always come because the computer is not being lazy like the spec says it's supposed to be. I'm just frustrated when it's not being lazy, and we've got a current bug in Rakudo where things are not being lazy enough. Hubris, excessive pride, the sort of thing that Zeus saps you for, and I've been sapped many times by Perl 6 laziness. So I figure it just, the definition just fits right in there. Perl 5 lists, of course, are eager. So here's a naive. In other words, if you read this program, you're going to say, that's not going to work. And yes, that's the point. To print a line following the first blank line in a file. So this is Perl 5 code. And what the programmer is attempting to do is to read all the lines from this file handle until they find a blank line, and then read the next line and print it. And then they close the file handle. What's wrong with this program? This part's going to slurp the entire file before it ever iterates. Right? Or it might do it as an optimization. But the semantics are such that this slurps the entire file, and thus, by the time you get to here, there's nothing left to read. Because you read all of the lines by this point. You just happened to stop iterating when you found a blank one, but they were all gone. They'd been tossed away by that point. Perl 6 lists are lazy. So here's the Perl 6 version now with lazy lists being there. So we will open the file, and then the command to read files from the file handle one at a time is .lines. So from this file handle, give me all the lines one at a time, and exit the loop if we reach one that is completely blank. And because this is lazy, it does what you expect it to do. It gets a line, executes the block. Gets another line, executes the block. And it keeps doing that until we either execute the last because we found a blank line, or because we ran out of files and lines in the file. And then at that point, we say, get the next line, and we say it. This probably doesn't handle the case very well where you reach the end of file here. Well, it handles it well enough. It throws an exception, but it would. But the point is, this is a lazy loop, and so these are only processed as they are needed instead of all at once at the beginning. So here's an example of laziness in action. When I wrote this line, laziness and action don't seem to go together. So I decided that it really needed to be laziness in action. Sorry. Alrighty. I promise I don't have any more of those. So here's my list of words. And what I'm going to do is I'm going to execute this block on that list of words. You see first not existing, but we'll fix that later. So we're going to map this particular block over words and then put it in this thing. And so this is going to then say hello, and this is going to say the second element. Now, if you're thinking about it in Perl 5 mode, what you're thinking of is I'm going to execute this map on all these words, and I get a list, and then I will store the result in upwards. And so what you would expect to see is loop, 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 as we go through the 5 times on this list, then the word hello, and then the word that's at index 2 with the with the letter converted up to uppercase. That's what you would kind of expect. But map is lazy. And so what you likely are going to get is going to be something like this. All this does is set up the map, but it doesn't actually do anything yet. It sets up the array and the block, but you haven't actually asked for any of the results. You've just asked for a reference to it. So it doesn't ever execute this block. So then we go say hello. Then we ask for the second one. I'll get your question in just a second. So then we ask for the second one. So we go through and process elements 0, 1, and 2. And then that's all we asked for. So it stops at that particular point and gives me the answer. Your question. It's a list. And the list is lazy. Inside of that list, there's an iterator. But it's hidden from you. Because
One level deeper, if I look it upwards, it's going to look to me like an ordinary array.
yes,
Referencing something that has.
it's going to look like a list, actually. There's a list type. And if you say, what are you? It's going to say, I'm a list.
How long it looks like.
Yeah. And for most things, you're just going to say, oh, that looks like on a list. And the fact that it's lazy, unless you do something funny to try and tease it out, you're not ever going to see it. So this slide probably answers a lot of that, which is internally lists have 2 parts. So every list we have 2 parts. We have a reified part. These are the parts that we've already gone through, iterated, discovered, calculated, whatever you want to say. These are the parts that we found the answers for. And then there's a generator part. And the generator part is like a closure or code that tell us how to get to the next element from what we've already produced. Yes?
Does that mean the higher order
It's this slide, yes. I mean, you still want to have the concepts and be able to make use of it. But yeah, a lot of the things that are in higher order Perl are built into Perl 6. So here's a range example. Now, ranges aren't lists. They're their own type, but it will show how the iteration process works. So here I'm going to set $R to be a range. And if I ask $R, what are you? It says, I'm a range. Now, the key operation for iterators is an operation called reify, which basically says, give me so many elements. So if I take that range and I say, reify 5 elements, and then show me what you got back, what this range actually does is it says, okay, you want 5 elements from this particular range. Now, reification actually is going to give you the whole thing, but the last part can be lazy. So it gives me 5 elements from the range, 100, 101, 102, 103, 104, and it says, and here's the rest. And so that's what actually gets returned from that particular element. So lazy lists manage the generation of elements on demand. And we can go a little bit further than that. So this is the same as what I had up there before. So after we get to the 104, if we say we need more elements, we just ask this range at the end, give me more. So, oops, that's not what I was going to do. Oh well, that's fine. We'll see it here in a second. So what this is actually saying is that since they're lazy, we can now have infinite lists because we can actually postpone generation of the parts to when we actually need them. So here's a list going from 100 to 200. We can actually take that and change this to be a range that goes from 100 to infinity. If we ask that range, give me 5 elements, it says, no problem, 101, 100, 101, 102, 103, 104, and the rest of them. Then if I go and say, well, on this one I need more elements, I can say I want 3 more elements. It comes back and says, okay, 105, 106, 107, and the rest.
Gee, what happens if you ask for the last element? Yeah, so
It throws an exception. I think. I think. How can I do that, though? Let's see. 100. No, because if I ask how long it is, right?
it's smart.
It's smart. It knows how long it is. That's not a problem.
Yeah, can you get Yeah, because infinity.
Yeah, that's technically wrong by Perl 6, but it throws an exception. It's the wrong exception, but it throws an exception. And if I have time in this talk, and if not, then in tomorrow's talk, I'll tell you why that's able to figure that out. Okay, so since a list can be infinite, our arrays can be infinite as well. So if you do my @ a is 100 to infinity and ask for the 10th element, it comes back and tells you 110. Now what it actually does when you ask for the 10th element is it fills in element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and index 10. And then it just saves the rest and says, whenever you ask for more elements later, I'll go generate them. So then if I ask later, I want elements 15 through 20, it comes back and gives me 15 through 20. So at that point it says, okay, I need 11, 12, 13, 14, all the way up to 20, generates them, and then comes back with the result. You can still do shift and unshift on that array. And it just remembers that the infinite part is at the end. So if you shift things off, you're moving the infinite part towards the front. And if you unshift, you're moving it back. But you can still do that. No, but you can push onto one. It's called plan. It's called plan. So, yes. So you can add something there. Now you may never actually get to that part. But there are some lists. There are some lists that may or may not be infinite, and so sometimes it makes sense to put something after a maybe infinite list. It won't actually, as it's implemented now. In theory, one could maybe make that work. I'm not going there. That's like version 6.1 of Perl. So it'll be ready sometime in 2050. So okay, so here's a Fibonacci example. Right now, this is the sequence operator. Other talks have talked about this, but basically we're creating a list consisting of 1, 1, the previous two elements added together all the way up to infinity. That's Fibonacci, right? So it actually comes back and it says, I was doing this in the interactive mode, so when it came back it said, okay, so the elements I see so far are 1, 1, 2, 3, and this is going to take a long time, so ... So then when I ask for A10, what happens is it fills out all of the elements following this generator up to element 10 and comes back and says 89. Then if I go back and say, I want element number 3, that's this one right there, it comes back 3. Now to get the 3, it just looks it up. It doesn't have to calculate anything because it already knew that one. I could say, give me all the elements up to 8, and it just prints them out. It already knew all those because I'd already generated up to 10. If I ask for element 12, then it says, okay, I need 11 and 12, and calculates those and do that. Basically, memoization for Fibonacci this way is built in, right? Because every time you ask for an element, it's getting stored in the array. Now, you could go muck with the elements in the array, and you'd be changing the array, but the generator part would continue to generate the things that you expect it to. So this is really handy for doing infinite lists. A lot of times in Perl 6, we'll just say, I know I need a list from 1 to something, so we just put the star there, and we let laziness take care of the rest. Yes?
Question really quick. What if you were to try assignments before accessing it? Would it calculate everything like 0 to 9 and then not calculate 10, or would it calculate 10?
It calculates 10 so it can replace it.
So you can do a plus equal.
Yes. So it calculates 10 so you can replace it. As yes, but you're but
For 1 million, I'm going to be using a lot of cores.
you would have anyway. Yeah. If you ask for element 1 million, then you're going to fill out to 1 million. The point being, you deferred that cost until you actually needed it, as opposed to incurring it up front. So a note about .elems, since we were talking about inf and stuff like that. .elems is decidedly not lazy. Okay? It tends to make things non-lazy, because when you say to a list, I want to know how many elements you have, and it's got a lazy part, it's got to go find out how many elements it has by generating all of the lazy part until it can either determine, 1, that it's infinite, or 2, until it reaches the end of that lazy list, or 3, you run out of memory. So a lot of people will use elems on arrays. It's just a habit that, it comes from Perl 5 programming and stuff. And that includes using a unary plus on it, because if you do plus on an array in Perl, then that says the number of elements in the array. In Perl 6 and Perl 5.
Perl 5.
Is it 0 plus? Oh, 0 plus. In Perl 5, I actually think of 0 plus as a unary prefix operator. So it means numify. So if you do words and here, and then I've created this lazy map again like I did before, where it's not actually executing this until you actually do something, and then I say hello, and then I ask for how many elements are in this map, then it actually has to go generate all the elements to tell me how many there are. And so it kind of destroys laziness. I have a question here.
Yeah, so with the Fibonacci,
You still get the Fibonacci answer, not the one in the array. That's expected if it's what you expected. There used to be a clause in the synopses that if you find yourself relying on a certain lazy behavior, then it's kind of not specified. So some things like that may or may not be specified.
That might be what you call erroneous.
So,
I'm going to warn you.
yeah.
But doctor, it hurts when I do this. We might change it.
So you want to avoid doing things like this, to check if an array is empty, doing plus A or 0 plus A. You don't want to do that because you'll find out it's not empty, but you've also reified the whole thing. If you just want to find out if an array is not empty, then just put it in a Boolean context. So in Perl 6, to check for a Boolean, you put a question mark in front. And that is asking, are you true or false? And this we can do lazily. If we have at least one element, then it's not empty, and thus it's true. And so this actually says, this is actually asking the array, do you have at least one element? If so, then it returns true. And you don't even have to have the question mark there because the if is already putting this in a Boolean context. So if you just say it naturally without trying to cast it, then it works out just fine. It would reify one element. Basically, it says, give me one element. If you're successful, it's true. If not, then you're not.
I can't know if the generator's
That's especially true for array parameters and subs. When people were contributing core functions into the Perl, Perl 6 core, into Rakudo's core library, a lot of times they would do things like they'd get an array as a parameter, and the first thing they'd do is ask it how many elements it had. And that destroyed any laziness that the array that was passed in might have had. So you have to kind of think, is there another way that I can figure out what my bounds are without having to ask for the number of elements? And it often becomes much more natural to do it that way. One thing is, if you want to get indices, because a lot of times what we want to do is we want to be able to say, I have these elements of the array, but I also want to have the numbers of their indices, 0, 1, 2, 3, 4, 5. Then you can use the .kv method. And this says, give me the elements of this array, or list, or whatever it happens to be, as a pair of values, the first one being the index, the second one being the value itself. So this is going to give me 0, orange, 1, lime, 2, cherry, 3, banana. And I grab those two at a time, the first one into K and the second one into V, and then I just print them out. It is lazy in the spec. It is currently not lazy in Rakudo because of a bug. Because it's really hard to make things lazy. So that bug will be actually fixed before the next release, because in my mind that's a big bug. Okay, so the opposite of laziness is called eagerness. And so you can ask a list to reify itself completely, or at least as much as it can, by simply saying, be eager. So here I have my lazy list that I created, and then I just say eager, and so it's going to go generate as many elements as it can, eagerly, before doing anything else, and then we get the actual hello. So you can see we get the loop there. It will stop at the detection of the infinity. So that it no, the lists have a way of knowing if they're infinite. If they're explicitly infinite.
You just got a generator that's going to generate forever, there's no way to tell.
Yeah.
So if I do eager
Depending on how you define the endpoint.
okay.
The star on the far right, the dot dot dot,
That says treat it like an infinite list, so it would stop early.
So eager is really just one item. It looks at the end of list and finds it.
it goes and generates as much as it can until it gets to the infinite part. Sometimes you discover infinity in a list where it wasn't at the beginning, but as you do processing, you discover it. And so it would stop there.
Yeah, is there an introspection?
It's gone. I know it's in the spec, but that's what. Yeah, it's in the spec, but that was an early attempt to fix like implementation number 2, and that begat implementation number 3 or 4, which no longer had an E operator. But I got tired of worrying about trying to make the spec match an implementation until we had one that actually worked. List assignment. So item assignment is when you have an equal sign with a scalar on the left-hand side. List assignment is when you have an equal sign with anything else. So list assignment is eager by default, which means that if you do an assignment to a list, it's going to treat the list eagerly. It's going to try and reify as much as it can as part of the assignment. If you have a scalar, then it doesn't. It's not eager by default. So that's why this one here, where I say upwards and do this map, that's lazily evaluated, and that's the example that I've been using throughout most of this presentation. But if I were to take that same map and assign it to an array, that would happen eagerly, because it would go ahead and try and fill out all of the elements of the array as part of this assignment.
That's mostly just to keep up with world-wide expectations.
Sync context, and yes, it avoids action at a distance effects. Because when you do an assignment to an array, most people expect that you're getting the values of the right-hand side and sticking them into the array. What you're not expecting is that you have a generator that's going to look up the value of a variable sometime in the future when you ask for it. And if that variable changed in the interim, then you get a different result. That's just very counterintuitive. So array assignments are eagerly evaluated. Yes?
Okay, call is made eagerly, but what was returned may be later.
And if you hand back, when it sends back a list, it's almost always going to be lazy. And then what's going to determine if it's eager or not is what you do with that list next. If you assign it to a scalar, it's going to stay lazy. If you assign it to an array, it's going to be eagerly evaluated to fill out the array.
What's going on here was trying carefully to balance out this notion of functional programming versus side effect programming, comparative programming. And when you're assigning to an array like this, an array is mutable. You can change it. So the expectations are that you are going to change it. Therefore, we better fill it in now and not do this lazy bit. Whereas if you're making Fibonacci and you're going to go modify things on the fly, that's really violating kind of the basic idea of functional programming, is that generate those values and you don't change them. So it's a finesse.
And here's the degree of finesse we have. So we have levels of laziness. And so we have strictly lazy, which means don't do anything in advance until you absolutely have to do it. Postpone it as long as you can. We have mostly lazy, which is you get the values if it's easy to do, but if you have to do any work, then put it off till later. We have mostly eager, which is you get all the easy ones that you can, handle the parts that you know are finite, but if you get to something that might not be finite, then you postpone it till later. And strictly eager, which is where you get all of the items that you can. If you can somehow know that that's going to cause you to work forever and ever and ever in a situation where you don't want to be working forever and ever and ever, then you can fail. Otherwise, just go along and eat it for tons of memory. Laziness, as we've been discussing, introduces a lot of action and distance effects, and so our design is to minimize them. There were lots of false starts until summer 2010. So we tried iterating, and you throw away information, and you end up losing data that you don't expect to. You try keeping everything, but that's bad if you're trying to do a pipeline type of thing. If your pipe is actually keeping all the data that you've already processed, then you're just eating up memory that you throw away in one gulp at the end. So the key insight that came through lots of discussions in summer 2010 is that our lists can be mutable, but our iterators are immutable. That is, they don't change. Now, how do you do that? Because by definition, an iterator is changing. And so we'll come back to that here in a second. And yes, I should have time to get to it. Okay, so what is a list? We've been talking about arrays because most people dealing with Perl 5 are comfortable with arrays and know what they do. A list is kind of the superclass of an array. It's just any sequence of objects. They're mutable. Lists are mutable in the sense that you can add something to the beginning of a list and you can take something from the end. You can shift, you can insert, you can splice, you can do all these things with a list. But it's the list itself that changes. The things that are in the list can be either mutable or immutable. So you can have a list of constants. You can add new constants to the list. You can take them off. You can add non-constants to it, but you can't manipulate the individual constants. So list is the class in Perl 6 that handles laziness, reification, and iteration. So it's the thing that has the reified part and the generator part. If you call a function like map, grep, if you do a gather take, anything where you're expecting back a list, then you're going to get a list object that's going to hide all the iterator details for you. So an array is a subclass of list, and the thing that distinguishes array from list is that an array is explicitly a list of scalar containers. It's a list of mutable things. All right? And so here's kind of an example for that. Here I have $fruit, and I'll give it the value of apple, and I'll create an array with the value 0, 1, and the value of fruit. And because it's eager, what happens is this array gets 3 elements, 0, 1, and fruit. So if we assign cherry to the one in index 2, and then ask what happened to fruit, what should happen to fruit? I heard nothing. Anybody else want to agree? Larry agrees. I agree. That's correct. Right? This is what we would expect from Perl 5, and we're trying to preserve that behavior. So the fact that we put the value of fruit into the array, we put the value here. We didn't actually put the variable into the array. Okay, so it comes back and says it's still an apple. And same thing for arrayrefs. So here I've got an array ref, I've created an array, and here what I'm getting is the value of fruit, not the variable fruit itself. And so it's still there. A list is different. A list is not a sequence of scalar containers, it's a sequence of objects, which can be containers or not. So if I have a list, and I say, okay, I want to create a list from 0, 1, and fruit, and I change the second element of this list, I'm actually changing fruit. Because the list contains fruit itself, the variable. And so if I actually say, what's the value of fruit, I'll discover that I did change it. That's really kind of the distinction between list and array. Larry looks perplexed. Yes, the at is what makes it a list. If the at weren't there, it'd be something called a parcel, which is coming up. Oh, so if you tried to assign to the 0 element of list, you're actually trying to assign to the constant 0, and you'll get an error. Oops, that should be can't assign to 0, but you can't actually assign to it because it's not a container. It's a value. Okay, flattening lists. Sometimes we want to group things based on context. So here's a couple of examples. So A is an array of 5 and 6. B is an array consisting of 1, 2, 3, 4, all of the elements of A, and 7. So how many elements does B get? Think Perl 5 here. What would the answer be? It would be 7, right? Because lists flatten. Okay? So it would be 7. The result of B would be 1, 2, 3, 4, 5, 6, and 7. It flattens out. Now, if those were brackets, of course, if those were square brackets, it'd be something else. Alrighty, so here's another one. So now I'm going to call a subroutine, and I'm going to pass it 1, 2, 3, 4, the values of A, and 7. In Perl 6, so the question is going to be how many arguments are passed to that subroutine? And the answer is, yeah, Larry, yes? No, it doesn't. How many arguments are passed? I'm not saying what happens when they're received. Okay? Not yet, anyway. 4. 4 things. What we get is we get this thing with 4 things in it are passed to my side. All right? 1, 2, yeah. A parcel, actually, as it turns out, and a 7. And we'll talk about parcels in a second. All right? So the answer is 4. This thing has 4 properties. So here we see we have the same syntax here. Sometimes we want the groupings to just flatten out. Sometimes we want to preserve the groupings as they were written by the programmer. So to handle that, we have these things called parcels. All right? So parcels represent syntactic groups of objects. So here I have a parcel, this whole thing. This parcel has 5 things in it. It has an integer, another parcel with 2 things in it, a fraction, and a hash. Okay? Parcels are unique that they can flatten in some contexts and they itemize in others. It depends on how you use them as to what the answer will be. The name originally for parcel came from parenthetical cells. We want to get rid of that name or that meaning, so the name of this might change, but I don't know. I can't ever remember what tuples are. So yeah, I believe so. I've made that analogy before. Yeah. You can have named arguments there. So the parcels themselves are immutable. You can't push or pop to them, but the elements, the things in the parcel, can be mutable. Despite the name, everybody looks at this and says, aha, it's the parens that create a parcel, and that's not correct. It's the commas that create the parcel. The parens are just there for grouping. Okay? So, except if you have an empty parcel, parens do create an empty parcel. We'll do that some other time. Most list operations cause parcels to flatten. So if I have an array and another array here, and I go through and I ask how many elements are in this parcel of parcels, it goes through and flattens everything out to give me 7. If I ask for the 5th element, it goes through and figures it out by saying this is 0, 1, 2, 3, 4, 5. That's the element at index 5, and give me that one. So they normally flatten out. If you want to make it explicit that you're flattening, then you can say flatten. And that causes parcels and intermediate flattening structures to flatten out. There is a list of lists operation that says, don't flatten them out. I want to make them like solid, like items. And so if you do something and say, give me a list of lists, and ask how many things do I have, it's going to say 2. You're going to have one parcel here, and another parcel here would be the 2 elements of B. Yes? Dot flat does. Lol is only one level deep, right? Or is it? Yeah, they work. They work. They did not work in 2012-05. They work in the release that's coming out on Tuesday. There's also a special value called nil, and it represents nothingness. It's an empty parcel in list context. If you use it like an item in a scalar context, then it gives you an undefined value. So if you say just return, then you get back this thing called nil, which means if you called this function in list context, it would be like there's no element there, an empty list. If you call it in a scalar context, you're going to get an undefined value. Parameter passing with lists. I have 2 minutes left. See if there's anything that I really, really wanted to cover. I think I can get through these. Okay. Perl 5 subs have a single parameter list. It's @_. Perl 6 has signatures. And so the parameters in the signature are bound to the arguments of the call. So here we have a function called, a subroutine called shout them, and it takes a single argument, @words. And so if we call that particular subroutine and pass it an array, it will work out just fine, because it can bind that. If I pass it a pair of elements here, this is going to actually throw an exception, because I'm passing 2 arguments to a subroutine that expects 1. I'm sorry, which one? $W. Oh yeah, it should be underscore. Sorry. UC still exists, right, Larry? Yeah. Yeah, that should be a $underscore. I better go fix that. So this one we called the function with 2 arguments, and therefore it couldn't match. But if I parenthesize this, then I'm calling this function with a single parcel, and therefore it's able to work. Next one. By default, arguments bind 1-to-1 without flattening. The number of things you put in the signature, that's the number of things that you put in your argument list. So if I say $X, $Y, $Z, and I call foo, it needs to have 3 arguments. If I pass it an array that has 3 elements, that's not good enough, because last words is a single thing. So it would say, I don't have anything for Y and Z. Those required parameters aren't there. If you need to flatten an array or a list into an argument list, then use the prefix, the pipe, to flatten it. So now this takes the elements of this particular array, and the first element would go to the first argument, the second element to the next argument, and so on down the list. No, because the .lol would still be a single list containing 3 things. Dot flat would give you a single list, right? Interpolating into an argument list is the prefix thing. That's the thing to do it. The positional role, I'm going to skip positional role. So how do you get the other behavior, where you can get as many arguments as you want into a single array? And the way to do that is called Slurpies. And you mark a Slurpy with a leading asterisk. And that means take all the remaining arguments, whatever you haven't already captured in the signature, and put them into a single list. So this is going to take all of the arguments that you pass to shout them and stick it in the array outside words. So more or less. So here, if I do this, it takes 3 arguments. Those all end up in this list. If I send it 1 argument, that's fine too. If I send it no arguments, that's fine. Okay? Now, the Slurpy parameter, this is both lazy and flattening. So if you send it a thing of parcels, it's going to flatten them out as it goes along. The list of list parameters are when you have things that you want to pass in that are lists, but you don't want them to flatten out like a Slurpy would do. And that's marked with 2 stars on the parameter. So here's a Slurpy. Right? It's got 1 star. And so here I'm going to pass, I'm going to call ABC with 3 arguments, a parcel, and an integer. And because of the single star, it's going to flatten out. 1, 2, 3, 4, 5. It's going to say them all one at a time. But if I put 2 stars there, that means I have a list of lists. And so it's going to preserve the parcel nature. So this is going to end up with 3 arguments, and it keeps track of the fact that it has 3 arguments. So if you need to pass lists as things and you don't know how many lists you're passing at the, or you're receiving at the outset, you can use the list of list argument. Yes, which is opposite from the original Perl 6 specifications, where the 2 stars were the steamroller operated that flattened until the cows came home. But yes, this means flatten less. This is the way that worked out. Yeah. Alrighty, I know my time is up, so I have lots of stuff which will go in tomorrow's talk, but I will take a couple of minutes for any last-minute questions. My talk tomorrow is in this room at 1:30. I will pick up from here. I will include some of the things that were discussed here, and we should have a good time. Yes, and back. So the question was, just to repeat the question, first to make sure I got it right and for others, is Perl 5, there's often already difficulty with array and scalar context. And here we've added flattening and list of lists and a bunch of other contexts that can make it more confusing. So far, based on what I've seen from comments on people on the channel, yes. It can make it a bit more confusing. I think part of that is people coming in from a Perl 5 background, and it doesn't really map onto their problem space. So they have a few things that they're trying to make it fit into an environment they already know, and the fit's not perfect, and that's confusing. Part of it is that there is just, a lot more to have to deal with, but I don't think it's intractable. I think that when we understand the problem, those of us designing and working with Perl 6 a bit better, we'll come up with better explanations than what I've given today or what we're doing that will make it clearer. There are a few simple rules that are guidelines that really help. Like if you see a $, it's not going to flatten. That means scalar. It's not going to flatten in that particular context. If you see a leading at, it is going to flatten. And so it'll do that. If it's grouped in a parcel, it means that the flattening decision is being deferred to something outside to try and figure out. So you can get some rules of thumb, and they're very consistent. We just don't know the right wording for those rules of thumb. Is that good enough? No, but I know. we do need to work on that particular part. I do know that this causes problems for people. Yes, up front.
So one thing I've found is that it's not just more complex, it's more complex and simpler. Your simple things are much simpler. When you don't have all this referencing and dereferencing, a lot of code is simpler. Now to master Perl 6, it is more complex. You need to know more. The simple things are also simpler. You've expanded on both sides.
That's a very, very good point. That yes, the simpler things are much simpler and much more straightforward. The last thing I'll do, and then I know I'm way over time, so I'm going to stop, is that part of the confusion that we see has been because of a changing spec and because of an implementation, whether it's Recruito or whatever else, that doesn't match the documentation or that doesn't match even what we understand to be the spec that has bugs. And so we're getting those cleaned up really, really quick. As I mentioned, some of the big bugs are going to be done even this week and have been fixed in the last couple of weeks. And so we'll know better by this time next year. All right, thank you.